So geometric forms are some of the most common and most important forms and structures of objects that we could learn in terms of drawing, as they can really help us to see things and also help us to build other things. So what are geometric forms? Essentially, they're objects that are man-made, geometric. They have certain characteristics in terms of, there's a regularity about them. They're based on basics of geometry. So one of the features might be what's called bilateral symmetry. So it means that bilateral, the two sides, are symmetrical. So we draw a line down the middle, we're going to get two sides that are similar. We get that again here, and we get that again here, depending on the angle of the box. But geometries, they're generally man-made, but they have a lot of interesting properties, and we learn the properties of these objects. Like I said, they can help us to see things, and they can also help us to build things. And these are the four most basic geometric objects: the cone, the sphere, the cylinder, and the box. And you can get as complicated or as fancy as you want, but these four basics will do most of what we need to do. So like I said, we can look at figures, and we can break figures down into variations of cylinders and spheres and ellipses or ovals and more complicated shapes happening here. Or if we're drawing objects like cars or industrial design, computers, things like that, they really can be reduced to just boxes, boxes with angles. And we can get those boxes in the right kind of perspective, angularity, proportion, and shape. It's really going to help drawing the object. So they're very, very useful ways of getting into drawing, thinking about drawing, and then building more complicated objects out of these simple shapes. So the most basic, the one we're going to start with, is the circle. So if you look at a circle, you'll notice that it fits perfectly into a square, which means that the width of the circle is exactly the same as the height of a circle. And where the circle touches the square is the midpoint of each side. Okay. Now this is really important information, because many things are derived from a circle. So that when we take such an object like an ellipse, for example, all of these rules still apply. So here is an ellipse. An ellipse is a circle seen from an angle. That's one way of thinking about it. But again, you'll see the same thing. Dividing it vertically, top to bottom, horizontally, right to left, it touches at the four corners. Instead of being a circle, you'll notice that an ellipse sits inside of a rectangle. And the rectangle can be oriented either way. Now, when we talk about ellipses, we tend to talk about axes, major axis and minor axis. So the major axis will be the longest line, and the minor axis will be the shorter line. In the circle, they're exactly the same, so it doesn't make much sense talking about it that way. Okay, so these two types of ellipses, whether we're looking at it from this angle or this angle, so what kind of thing might be made from this? Well, bowls, for instance. Anything that's round, that's not seen from above, is going to be squashed in this direction, maybe the same width. This direction. Over here, it's different. This is the narrow, and this is the longer one. So what kinds of objects might this be? Wheels, for example, on cars. So we see them from the side. So by understanding this structure, what's going to happen is there will be a lot of things you will encounter in drawing that seem to look one way, but if you know that it is in fact an ellipse, then what you think you're seeing cannot be true. In other words, the laws of an ellipse can help correct what your brain is telling you you're looking at. All right, so I'll explain this as we go along. So one way to think about an ellipse is that it's really just a circle at an angle. All right, so if you had a bowl and you looked down at the bowl, it would be round. But if you looked at the bowl from an angle, so you're above the bowl, it would not be a circle. This is not a circle. This is an ellipse. It's a circle turned down, almost. So if you had tiles on the floor and you drew a circle inside each tile and you stood up and looked down at the tiles, this is what they would look like. So technically it's an elliptical shape. Now, what's important about this are several things. One, hang on one second. Whether we put it into perspective, so this is a square lying down, and these are called vanishing points. Don't worry about this. We'll come to this later. Whether it's lying down in a square or just symmetrical as an ellipse, they're the exact same shape. All right. Why is this important? Because there's a lot of misunderstanding about what's happening here. I've come across books and magazines that talk about drawing that tell people all sorts of weird things as a result of this. So for example, what happens in perspective is what's further back is smaller than what's in front. All right, and that's true. As we go back in space, things shrink. Now, the idea is if this is a circle in a square and the back of the square is smaller than the front of the square, then if this is the midway point, then the back of the circle is smaller than the front of the circle. And it is. But an ellipse is not that. Okay, so this is a circle in a square, but what you want to make sure you do when you're drawing ellipses is do not make the back smaller than the front. Ellipses are exactly symmetrical. So why is this happening? It's because this is actually touching here, but because the box is getting bigger and bigger as it comes out, the widest point of the ellipse is down here, not here. All right. It might look like this is the widest part, but think about it. This, the circle is still coming out. This is the widest part, which just so happens to align with this. All right. So this is the middle of the circle, but this is the middle of the ellipse. And so this red shape is the exact same shape here. So this is important. You want to keep this in mind. When you make ellipses, the height from the middle to the top or the middle to the bottom is exactly the same. The distance from the middle to the side or the middle to the other side is exactly the same. It's entirely symmetrical in every direction. Another thing about ellipses is that they change the minor axis, the smallest one, gets smaller and smaller and smaller and smaller as it comes to the horizon line. Now, another term for the horizon line is your eye level. So if you took a bowl and you held it up so that bowl was lined up perfectly with your eyes, you would only see a line. You would not see any kind of ellipse. But if you drop the bowl and you could see into the top, you would see a little bit of a distance between the back of the bowl and the front of the bowl. And as you drop the bowl lower, that elliptical shape would get rounder and rounder and rounder. Likewise, if you went up from your eye level, it would be exactly the same. It's just reversed. Okay, so this is really important when it comes to ellipses, because your eye level determines the shape of the ellipse. The closer something is to your eye, the flatter and closer to a line it is. The further something is away from your eye, either going down or going up, the rounder the ellipse becomes. Okay, so returning to our ellipse. When you're drawing an ellipse, you want to be completely symmetrical all the way around. This is very hard to do. So drawing ellipses takes a bit of practice. All right, very common mistakes when people draw ellipses are some of these things. So if you come over here, the diamond shape, that's very, very common when people draw ellipses. They go to the side and they have a relatively straight line. You want to always have a curved line. This is what I just talked about. People often think that the top of the ellipse is smaller than the bottom of the ellipse. It's not, so avoid that. This is much better, but you can see that this is more angled and these three sides are all round. So you want to be a little more consistent. This is a very common mistake. People tend to make one side of the ellipse round and the other side more pointy. Same thing happening here. Or they tend to make both sides pointy. Remember, there has to be a curve here. There has to be a curve here and that curve there. What's happening here? Can you figure it out? It looks like a good ellipse, but you'll notice that the left side is higher than the right side, and the left side should be completely level with the right side. So this is an angle, and we don't want that angle. And over here we have the same thing happening. We have an angle. The right is higher than the left, and the left is pointier than the right. So drawing this kind of shape takes a lot of practice. All right. So what I'd like you to do is just practice your hand drawing these kinds of shapes, and you'll see that you have a natural predisposition to do, either something like this or something like this or maybe something like this. And if you can identify what you do, then you know that that's what you have to work on. So if you're making diamonds, you know that you have to curve your lines a little bit more. So I want to take you through how you would draw an ellipse. All right. So let's start on your paper by just making a rectangle. Doesn't matter what the sides are. Doesn't matter the dimensions. I don't even know what these measurements are. So just make a rectangle, and a rectangle will be, one side is longer than the other. And then we need to find the midpoints of the rectangle. What's the middle of the top and bottom and the sides? Any kind of shape like this, the way to find the midpoint is to draw a diagonal through the 2 points. The 2 corners, sorry, the top corner and the bottom corner on opposite sides. And what you'll get where they intersect is the middle going vertically and the middle going horizontally. So try that. Take a ruler, draw any kind of box, make sure it's square, meaning it's 90 degrees, and then connect your sides, and it should roughly give you, not roughly, exactly give you the midpoints. The next thing I want you to do is, once you've established the midpoints, is we've been doing this in pencil, I want you to shift to charcoal. To vine charcoal. Now these are sticks. They're pieces of wood that are burnt. They're crude. They don't have points. They're very hard to manipulate. But I want you to get used to them very quickly, because we're going to be using all various types of charcoals and pencils throughout the course. And I don't want you to get too bogged down by being super, super precise. There are some assignments where we are going to be very, very precise, and we're going to use pencils and rulers. But most of it, we're going to be using tools that are less precise, more expressive, and that's why we have such a large pad that we're working on, because this point is pretty broad, it's pretty thick, and it's also messy. You're going to get messy marks all over your paper, and I don't want you to get hung up by being too perfect, too precise, and more importantly, too clean. All right, drawing is about making a mess. If you're not making a mess and you're not making mistakes, then you're not learning how to draw. Okay, so what I want you to do is then take your charcoal and draw little curves in each corner. So the curves on the sides are going to be bent more, and the curves on the top and bottom are going to be bent less. So just give them a curve. That's a good way to start. And then connect your dots. Connect your curves. All right. And you can see it's going to be messy, but try and keep a nice curvature all the way around. You can see it's a little flat here, but that's okay. If you can see that that's kind of flat and not curvy enough, then your eye is getting pretty well developed. All right, so then you're going to draw your ellipse inside the shape using your charcoal. So try that and stop this video as often as you want as you follow along and try to do these steps. Now once we have this ellipse, we can see that if we took the side of the box and we extended it, and we extended the central axis, which is the minor axis, we could, using those points, make another ellipse at the bottom. All right, using the same height, you can draw another box here. And what that'll give us, if we put in the sides, is basically a cylinder shape. So a cylinder really is just 2 ellipses connected by 2 straight lines. All right, so this is the kind of thing you want to practice. You are going to be, posting one of your drawings to the Padlet board for us to look at and talk about. But you don't want to post your first one. You want to practice this a few times. You want to kind of get the hang of it so that you know what you're doing. And to see how, the ellipse is kind of the basis of many, many things. And so is this whole idea of a central axis. You can see that, for example, we can erase the whole ellipse and keep the bottom ellipse. And as long as we use the central axis as our point, we can create a cone. And a cone, the structure of the cone, is symmetrical, bilateral symmetry. It's got your middle line. And the apex of the cone is always in the center line. So people, when they're drawing cones, for example, they have to put the apex to one side. And that's how you know it's wrong. So if you know how wide your ellipse is, you know where the midpoint is. And if you go straight up, you're going to get the point. Now what's crucial is this is a right angle. This is, in other words, 90 degrees. The ellipse, this side and this side are the same height. You're not going to get an angle with this ellipse. Let's see if I can draw an angle. I'm trying with these crazy tools. There we go. That's an angle. We're not doing that. Okay, we're going straight across. So that's what we want to be doing in our picture. And if we continue down, we can see that that same ellipse can also be turned into a bowl, and the rules still apply. We got that central axis, we got the width of the major axis here, we've got our ellipse, front of the bowl, bottom of the bowl. So it's a very versatile shape, one that you really will need to know and learn how to draw. But more importantly, it's the structure, it's the symmetry, it's the idea that the top is the same distance as the bottom, the right is the same as the left, and that where these two axes meet is 90 degrees. Okay, so one of our drawings is going to be a cylinder, and if you look at the cylinder, you'll notice that it has an ellipse at the top and it has an ellipse at the bottom. And if you notice, even though the major axis is the same, the minor axis, which means the kind of the width of the ellipse, has changed. We know this is below our eye level because we can see the top. So our eye level is somewhere up here. So we're looking down on this object. But when we go to the bottom of the object, it's further down. And as you remember from the previous slides, as we start to go further down, we get more and more round. Okay, in other words, the minor axis gets bigger. So that's why this is a different kind of ellipse than this. So pay attention to that. You're going to see that in your drawing. You're going to see that the distance, the axes for the corners of the ellipse are 90 degrees to the central axes. Okay, and you'll notice also something else. Now, here's our eye level. We're at the top. As things go away from our eye level, they go down. Perspective tells us, and we'll come to perspective later, things get smaller. So notice how the bottom of the cone is narrower than the top. So these green lines are the width of the top. Okay, so this does happen with objects, and I'm going to give you a choice in this class. You can either begin to narrow it if you see it, but if you don't see it and you made the width of this the same as the width of this, that would be okay. That would be fine. This is called 3-point perspective. We'll come to that much later in the course. Don't worry about it. But it is something you will see. And cameras will also tend to exaggerate some of these artifacts. Okay, so if you see the bottom as a little narrower, that's perfectly fine. If you don't, that's also perfectly fine for what we're doing in this course. You're also going to be asked to draw a bottle. Now, how would you start this bottle? You're looking at it. It looks like a cylinder. It's a cylinder here. This is a dome, and this is another mini cylinder with some details. How would you go about drawing this? Well, the first thing you would do is try to establish the proportions. We saw this in the previous video. So cite the width, and then cite how many widths go into the height, and mark this on your paper. Okay, so your first width would be arbitrary. You make it 3 inches, 2 inches, 4 inches. I don't know. It depends on how big your paper is and where you're putting it. But once you've got your width, you'd measure it with your pencil and just go up the correct number of times. All right, so that's going to give us our basic proportion. Then you want to put your central line in. The central line is crucial. The middle axis really helps you see both sides, and it helps you get your symmetry right. And then you're going to sketch in your ellipse on the bottom. And how do you do that? Well, you're going to estimate what you think is that curve right there. And make sure the curve doesn't go below this line. This is the bottom of the bottle, the lowermost part. So just kind of guess what you think that curve is, and then you're going to repeat it above that line so it becomes symmetrical. The next thing you're going to do is you're going to figure out, well, if I come straight up the bottle, at what point does it curve? And that's what you're going to have to do with your sighting technique. And where it curves, I want you to put another ellipse. And you'll notice this ellipse is a little bit narrower than this ellipse. And you're going to keep going, oops, sorry, wrong direction, till we come to this ellipse. All right, it's a smaller ellipse widthwise, obviously, a little bit smaller this way proportionally. And then you're going to figure out what's the distance to that. So you're going to have to guesstimate where these points are, and this takes practice. All right, so that's that sighting technique of holding your pencil out, lining up the tip, lining up your thumb, using your eye, one eye, and guessing, how far things go. And the same thing will happen with the third drawing that you're going to be submitting, which is the bowl. Again, you'll figure out what is the relationship of the width, B, to the height, A. And here we can see that B is longer than A. How much longer? Well, you got to figure that out. So you measure this, and you see that might go, to about here, and there's a little bit more. So this is a little more complicated. If it was square, they'd be the same. If it was 2 to 1, it would be easier. So this is where you're going to have to use your own kind of judgment. And then you're going to be proceeding by definitely putting in your center line. This is really important because it helps you get the two sides correct. If you don't have this center line, it's hard to see, are these the same shape? Are these the same distance from the middle? Things like that. Is this the same curve as this? So that center line is really, really important. And then you might take, the distance of the ellipse. Here's the height of the ellipse to the bottom of the ellipse. And you could cite that, again, with your pencil, and ask yourself, how many of those go into the height of the bowl? And here you can see that if I did 3 of them, I would go to here. So it's, 3.5. So again, you want to work on practicing these techniques. I know it sounds very technical, a lot of measuring, but this is the kind of thing that at the beginning of the course we will measure and we'll be very precise with. But later in the course we will use these techniques mostly to get us out of problems. You're making a drawing and it just doesn't look right, something's wrong. You're going to apply the sighting technique, you're going to measure, you're going to go, oh wow, I was at 4 and it's less than 4, so you're going to bring your bowl up. Things like that. All right, so these are the 3 drawings. I want you to do them in pencil first and then outline the major shapes in vine charcoal. Do not do the shading. They're just going to be line drawings. And take all of your images and put them on one JPEG. Now you can do that either by drawing all 3 on the same piece of paper or taking 3 drawings on 3 separate pieces of paper and putting them into one image. Do not post 3 drawings, just post 1 drawing. All right, hope that's clear. It's a lot of information, but it's the kind of information we're going to be coming back to again and again and again.